Complement. What is the complement? What do you mean by complement? What is the requirement of the complement? Okay, that we are going to see here. So complement is required to perform the subtraction operation with the help of addition operation. And then we are going to see two different types of the complements, diminished and radix complement. And again, you see that we perform the arithmetic operation with the help of diminished as well as radix complement. So still you didn't subscribe our channel, please subscribe it and share with your friends. Like your whatever your requirements is there, that also you can write in the comments. So first we'll talk only about the complements. So complement is used in digital computers to simplify the which operation? To simplify the subtraction so that we can perform the subtraction operation with the help of addition. So that is the main purpose of the complement. So we have two different types of the complements. One is called as the diminished complement, another is called as the Radix complement. So this diminished complement is represented by R minus 1 apostrophe S, and Radix complement is represented by R apostrophe S. If, suppose for example, if base is 10, so in that case, if base is 10, then diminished complement will be 9's complement and Radix complement will be 10's complement. If base or radix is 2, then diminished complement is the 1's complement and we have radix complement is the 2's complement. Okay. So first we are going to talk here about the diminished complement. Okay. The diminished complement, it is represented with help of R minus 1's complement. So we'll see first how this computer is going to work, how the algorithm is going to work to obtain the diminished complement. So that algo we'll see. After that, we'll see in the general way how we can find the diminished complement easily. So here the logic is that whenever numbers are given for which we are trying to find the diminished complement, if that number having n digits, okay, like suppose it has 5 digits, 6 digits, okay, n is the digits in number, or we can say that number of digits, okay, in number capital N. So number is represented by here by capital N. Okay. And the radix is going to be R is here, radix. So first of all, for that expression is given, that diminished complement is given as R to the power N minus 1 over all minus N. Okay. So where R to the power N is the 1 followed by n zeros. Okay, how many digits are there in that particular number? That much zero we are going to utilize here. Okay, that is meaning here 1 followed by the number of zeros. Okay, what is the expression? R to the power n minus 1 minus capital N. Now we'll take one example. Okay, suppose we are going to talk about the decimal number. We are much familiar about decimal. So radix is taken as the 10 here in decimal number, and that number what we are going to take, that number is 5, 4, 6, okay, 7, 0, 0. This is the number for which we need to find the diminished complement. So what is the logic? R to the power n. So here, what will be the R to the power n? Since here n is what here? 1, 2, 3, 4, 5, 6. It has 6 digits. N is 6. So R to the power n will be 1 followed by the 6, 0. Then what we have to do? R to the power minus 1. So 1 followed by 6, 0, minus 1. So this value is going to become how much? 1, 2, 3, 4, 5, 6, 9. Okay, so 6, 9 we are going to obtain. Next, what is the expression? R to the power minus 1 overall minus n. So finally what we have? 6, 9 is there. Okay, that is being subtract. So from this, what we are going to subtract? Capital N. Capital N value is M5, that is 5, 4, 6, 7, 0, 0. So once subtract this, so 9 minus 0 is the 9. Again, 9 minus 0 is the 9. 9 minus 7 is what here? 2. 9 minus 6 is 3. 9 minus 4 is the 5. 9 minus 5 is the 4. So this 4, 5, 3, 2, 9, 9 is the diminished complement. Means what's which complement? This is the 9's complement of given number. 9's complement of n. N is what here? 5, 4, 6, 7, 0, 0. Okay. This is how we are able to obtain the diminished complement. So this is what you have seen. This is the way how algorithm is going to work. But here we can obtain this diminished complement directly. In case of decimal, what we are going to do? In case of decimal, each digit is subtracted from the line. Each digit of n is the given number, is subtracted from 9. Okay. So if you see that in that way also we can see, or we can take some another example also. On the basis of that we can perform. So here also if you're going to subtract each number, so what is the number? 5, 4, 6, 7, 0, 0. So subtract from 9. So 9 minus 0, 9. 9 minus 0, 9. 9 minus 7, 2. 9 minus 6, 3. 9 minus 4, 5. 9 minus 5 is the 4. So same digits we are going to get, even we are going to do it directly. So in the exam, if they're asking you objective questions, so you should do directly. This one, what we have seen, how algorithm is going to work, how computers is going to perform the 9's complement or diminished complement. Another, we are going to take example for the binary numbers. So binary numbers, if example 1, 0, 1, 1, 0, 0, 0. So again, you can do how we are doing in the by the help of algorithm that you can do, okay, in the similar way. But here we are going to do the directly. So here what we have to find? 1's complement. So radix is 2. So diminished complement is what here? 1's complement. So how we find the 1's complement? 0 will be changed to 1. Okay, what is the rule? 0 will change to 1, 1 will change to 0. So on the basis of this, if you see from this LSB side, 0 will change to 1. Again, 0 is changed to 1. 0 is changed to 1. 1 is changed to 0. 1 is changed to 0. 0 is changed to 1. 1 is changed to 0. Okay, that we are taking these numbers. So finally, this is the 1's complement of the given numbers that we are able to obtain directly. In the way of algorithm, here also you can obtain in the similar way. Okay. So this is how diminished complement is obtained. Next, we are going to see about the radix complement. So how we'll obtain the radix complement? We can see for the decimal as well as binary numbers. So the radix complement is given as r to the power n minus capital N. Okay. So r to the power n is what? It is the same as before. Okay. 1 followed by zeros. That much. How many digits are there in the number? This r to the power n minus n also can be written as r to the power n minus 1 minus n plus 1. So we are adding and subtracting 1 here. So finally we can have r to the power n minus 1 minus capital N, okay, plus 1. So what we are saying, this portion is same as the diminished complement, okay. So first we have to obtain the diminished complement, then in that if we'll add 1, we'll get the Radix complement, okay. So what is the logic? First we need to obtain the diminished complement, then if we'll add 1, we'll get the Radix complement. So already we have seen how to find the, first we'll see that by the help of algorithm, later we'll discuss how to find directly. So now we are taking one decimal number as the example, that is the 2389. This is the decimal number. So here we have to find the tens complement. So Radix complement means what here? Tens complement we need to find. Okay. So now to obtain the tens complement, first we have to find the nines complement. Okay. So this nines complement means each digit should be subtracted from the 9. So 9 minus 9, 0. 9 minus 8, 1. 9 minus 3, 6. 9 minus 2 is 7. So 7, 6, 1, 0 is what? It is the nines complement. So what will be the tens complement? In 9's complement, we have to add what? 1. So 7610 plus 1. What will obtain here? 7611. So that is the, what is the value? That is going to be the tens complement. Now, how we'll obtain tens complement directly? Without the help of diminished complement, directly how we are going to obtain? What is the rule? Leave the non-zero digits. So here when we talk from the LSP sides, okay, so first we follow, leave the 0. Okay, leave the 0, what we'll do? Unchanged. From the LSP, if you're getting the 0, so that 0 should be unchanged. Okay, after that, first non-zero digits. Okay, first non-zero digit, subtract from 10. Subtract from 10. Okay, and remaining digit, subtract from 9. Okay, that is the logic. So now if you take the example of this given number, if you want to do the perform the direct operation, so in that case, what is going to happen here? What is the number from the LSB side? 9. 9 is what? Non-zero numbers. Okay, if 0 is going to occur in the initial, if 0 is going to occur, that 0 will leave. Okay, so for example, you take another example. If you have 3, 2, 5, 0. Okay, for this we want to find the tens complement. So we'll try to find the tens complement directly. So what is the rule? Leave the zeros from the LSB side unchanged. If 0 is going to occur, before non-zero digits will leave unchanged. So we have written 0 as it is. Next, 5 is what here? Non-zero digits. So 5 should be subtracted from the 10. So 10 minus 5 is what? 5. Remaining digits should be subtracted from the 9. So 9 minus 2 is the 7. 9 minus 3 is the 6. So 6750 is the tens complement of 3250 that we can obtain directly. Similarly, we'll try to find for the binary numbers. So for binary numbers here, we have to find the 2's complement. What we'll find? 2's complement. So first we'll see how we can do with help of 1's complement. Later we'll see how we can obtain directly. So number is 1 0 1 0 1, okay, 1 1 0, for example. This is the number for which we want to find the 2's complement. So first what we'll do, first we'll find the 1's complement of number. So what will be the 1's complement? What is the rule? 0 will change to 1, 1 will change to 0. So we'll move from the LSB side. So 0 is changed to 1, 1 is changed to 0. Again 1 is changed to 0, 0 is changed to 1, 1 is changed to 0, 0 is changed to 1, 1 is changed to 0. From LSB we are moving towards the MSB. This side is called as the LSB, okay, and this one is called as the MSB. So now to obtain this 2's complement, what we have to do? We have to add 1 in this. So if we'll add 1, okay, so what we'll get here? 1 plus 1, sum is 0, carry is 1. So now we have 0 plus 1, 1. So 0, 1, 0, 1, 0. So this is the 2's complement, okay, of the number what we have taken here. That is the 0, 1, 0. That is the 1, 0, 1, 0, 1, 1, 0. Okay. Or this is what here 2's complement. Now, what is the rule to find the 2's complement directly here? Okay. So what is the rule? Leave zeros unchanged. Okay. Leave 0 unchanged. And leave first non-zero unchanged. So be careful here. 0 is also unchanged from LSB side, and leave first non-zero also unchanged. So here non-zero will be always 1. So that also should be unchanged. And for remaining digits, 1 will be changed to 0, 0 will change to 1. So here LSB side what we have? 0. So keep 0 as it is. Again we have 1. This is the first non-zero digit, so it is also same. After that, this 1 will be changed to 0. Then this 0 is changed to 1. Again, this 1 is changed to 0. This 0 is changed to 1. And 1 is changed to 0. So what you see that these both values are same. Okay. How we have in case of we are finding 2's complement by using 1's complement. Okay. So directly also we can find. So what is the rule? Leave 0 unchanged. First non-zero also unchanged. And remaining, you have to change 0 into 1, 1 into 0. So this is the how we are able to find the diminished complement as well as Radix complement. Next we'll see, again if you see that here, this 9's complement and 10's complement, how we can obtain, okay, directly in the fast way for the given number, that also we can see easily. Okay, so here for the 9's complement, okay, we are taking some example. If you have 2, 6, 7, 9, 0, for example, okay. So for this is the given number, we have to find the 9's complement. So 9's complement, what is the rule? Subtract the each digit from the 9. So we'll move from here, or we can see that if you are writing the number here, so easily we can see 2, 6, 7, 9, 0. 9's complement, each number is subtracted from the 9. So 0 is in digit here. So 9 minus 0, 9. Again, this digit is subtracted from the 9. So 9 minus 9, 0. Again, this one is subtracted from the 9. So 9 minus 7 is 2. 9 minus 6, 3. 9 minus 2 is what here? 7. So this is the 9's complement of the given number. And if you have to find the 10's complement. So what is the rule? What we are going to do? If you have to go with 9's complement, then 10's complement, then we have to add 1. So after adding 1, we get the 10's complement. So 9 plus 1, 0. 0 plus 1, 1. And remaining is what? 2, 3, 7. So this is the 10's complement. Now, for the same number, if you want to find the 10's complement directly, okay? So what is the number? We have 2, 6, 7, 9, 0. We want to find the 10's complement. So what is the rule to find the 10's complement directly? Leave 0 unchanged. So from this is our LSV side, this is the MSV side. So here we have 0. So this 0 leave unchanged. Again, the first non-zero digits should be subtracted from the 10. So 9 minus 10, 1. Remaining digits should be subtracted from the 9. So 9 minus 7, 2. 9 minus 6, 3. 9 minus 2, what we have 7. So what we can see that both result, this and these are same. Okay. How we are going to perform these complements. So here we have 9's and 10's complements. Okay. Again, similarly, we have 1's and 2's complement. Okay. So number is given what here? 1, 0, 1, 0. So what is the rule to obtain the 1's complement? Change 0 into 1 and 1 into 0. Okay. So this 0 is changed to 1. 1 is changed to 0. 0 is changed to 1. 1 is changed to 0. This one is the 1's complement. To obtain the 2's complement, add 1 to the diminished complement to the 1's complement. So 1 is added here. So 1 plus 1, sum is 0, carries 1. Again, we have 0 here. Previous carry 0 plus 1, 1. Again, this 1 is same as it is. This 0 is also same. Okay. This is how we are finding 2's complement. If you want to find directly, okay. So what is the given number? Given number is 1, 0, 1, 0. So now this 2's complement. What is the rule? Leave 0 unchanged from the LSV side. This is the LSV. This is the MSV. 0 unchanged. First non-zero also unchanged in case of binary. So it is 1, 1. Now this 0 will change to 1. 1 will change to 0. So what you are seeing that both results are same. And 9's complement, one more example. If you have 1, 3, 2, 5. So we are subtracting each digit from the 9 to obtain the 9's complement. So 9 minus 5, 4. 9 minus 2, 7. 9 minus 3, 6. 9 minus 1, 8. And to obtain the 10's complement, you have to add 1. So 4 plus 1, 5, 7, 6, 8. Okay. And to obtain the 10's complement directly. Okay. Directly, if you want to obtain the 10's complement, number is 1, 3, 2, 5. So for this, what is the rule for the 10's complement? Leave the 0 unchanged, but 0 is not here from the LSB side. After that, subtract the non-zero, first non-zero digit from the 10. So 5 is here, first non-zero digit. So it will subtract it from the 10. So 10 minus 5, 5. Remaining digits should be subtracted from the 9. So 9 minus 2 is the 7. 9 minus 3 is the 6. And 9 minus 1 is 8. So what you are seeing that both results are same. So like this, we are able to perform the complements. Next, it is important to see the complements use, complements applications. That what is the complements applications? To perform the subtraction with the help of addition. How to simplify the subtraction operation by the help of addition. That is the main purpose of the complements. So here in the exam, mostly they are ask you about 2's complement related operation. Okay. So now here we are going to take another example where we are going to take one number x as the 1 0 1 0 1 0 0. Another number we are taking as the y, that is 1 0 0 0 0, and then we have 1 1. So now here we'll see how we'll perform the x minus y, as well as we'll see how we'll perform the y minus x, what will be the difference. Okay. So here first we'll talk how to find the x minus y. So when we are finding x minus y, x is the minute, y is the subtrahend. Okay. So for the subtrahend, we are going to take the radix complement, that we call it the 2's complement. So subtrahend 2's complement will be added to the minute. So first you can take 2's complement of y. So 2's complement of y we try to find directly. So what is the rule? If 0 is there from LSP, unchanged, first non-zero also unchanged, remaining bit will change 0 to 1, 1 to 0. So here what you see that digit what we have, LSP digit is what here? 1. So that means this 1 will not change. Okay. So this 1 we are not changing. We're keeping as it is. Remaining digits will change. So next what we have 1, it will change to 0. Remaining 4 zeros will change to 1. Okay. Then last one will change to 0. This is the 2's complement of y. Now it will be added with the x. So x value what we have 1 0 1 0 1 0 0. And now this 2's complement of y will be added here. So 0 1 1 1 1 0 1. Now we'll perform the addition operations. Sign is plus. So 0 plus 1, we can change the color, so better understanding. So now 0 plus 1, what we have? 1. 0 plus 0, 0. 1 plus 1, sum is 0, carries 1. Next 0 plus 1, 1, and this carry 1 plus 1, okay, sum is 0, carries 1. Now 1 plus 1, sum is 0, carries 1, but this 0 will be added with previous carry, so there is 0 plus 1 is what here? 1. Now 0 plus 1, 1, and this carries 1 plus 1, sum is 0, carries 1. 1 plus 0, 1. This carries 1 plus 1, 0, carries 1. So now what you see that here in the given number digits are 7, but in the result we are going to obtain the 8 digits. So this last digit is what? Carry. So this carry should be discarded. Okay. So here you are going to discard the carry, and that remaining obtained sum itself is the value for the x minus y. So whenever you are going to obtain the carry here, that means it shows that x is greater than y. Okay. Then only you will obtain the carry. Whenever minute is greater than subtrahend, you will obtain the carry, and obtained carry itself is what here. So that should be discarded, and remaining digit what is as the sum, that is going to be the x minus y. You can verify also x is what here. If you check the value, we have 64 plus 8, 80 plus 4. This decimal value is 84. Again here 64 plus 3 is what here? 67. Now if you subtract this, 14 minus 7, 7. 7 minus 6 is 1. So answer should be 17. So here also we have 17. This value is 16 plus 1, 17. Okay. So whenever minute is greater than subtrahend, you have to discard the carry, and obtained sum itself is the x minus y value. Okay. So here x minus y is what? 0, 0, 1, 0, 0, 1. Okay. This is the when minute is greater than subtrahend. Now we are going to do the reverse of this, y minus x. So y minus x means here y is going to become 67 and the subtrahend is going to become 84. So once we subtract this answer should be what? Negative 17. So when minute is smaller than subtrahend, okay, here x is here what we have changed the value, okay, y become here minute, x becomes subtrahend. So when minute is smaller than subtrahend in this case, so then what will happen? The obtained sum is the 2's complement. Then again for that sum, you have to take the 2's complement. Then we have to add the sign. So now here, what is the y value? Y is 1, 0, 0, 0, 0, 1, 1. Now with this 2's complement of x will be added. Since here now subtrahend become x. So we have to take the 2's complement of x. So what is the x value? This is the x value. So from the LSB side, what we are saying that we have 0. So that 0 should be unchanged. First non-zero digit is what? 1. That also should be unchanged. And remaining digit will change. Okay, 0 to 1, 1 to 0. So finally, on the basis of that, what we'll have here, this 0 will change to 1, next 1 to 0, 0 to 1, 1 to 0. Okay, so we have taken x value from here. Now we'll perform the addition. So 1 plus 0, 1, 1 plus 0, 1, 0 plus 1, 1, 0 plus 1, 1, again 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1. So here what we are saying that we don't have extra bit here. Okay, exactly same number of digits are there. How many are there in the manual or subtrahend? So before subtraction, we'll make the number of digits equal. So how we make the number of digits equal? By adding 0 in the left side. Okay. So now this obtained sum is not the value of y minus x. So now what we have to do? We have to take the 2's complement of sum. Okay, 2's complement of sum. In that we have to add the negative sign. So 2's complement of sum. So this is the value. Okay, 2's complement here we have to take for this sum. So now we are going to consider these values. So what is the rule? 0 means unchanged. First non-zero also unchanged. So first non-zero is what here? 1. Now next 1 will change to 0. Next 1 change to 0. Next 1 change to 0. And 0 will change to 1. Next 1 0. Next 1 0. Okay. For this we are moving from the right to left. So now we have y minus x. So y minus x is what? We have to add the negative sign, negative 0, 1, 0, 0, 0, 1. So, okay, so we have to find the 2's complement of the sum. Then we have to add the negative number. So that is going to be the value, actual value. Okay, this is how we have done the subtraction by the help of radix complement. That is the 2's complement. Okay. Similarly, we can do the subtraction by using 1's complement. So in the 1's complement, you'll see that we have something we call as the in around condition that we are going to see. When we'll get in around condition? When minute is greater than subtrahend. So here we have to check the digits. Number of digits should be same in minute as well as subtrahend. So fortunately, both are same. So now 1 0 1 0 is the minute, subtrahend is the 1 followed by 000. So now we have to take the 1's complement of the minute. Okay. So 0 will change to 1, 1 will change to 1. So this is the 1's complement. Okay. And this minute is 1 0 1 0. Now we have to perform the addition operation. So 0 plus 1, 1. 1 plus 1, 0. Carries 1. 0 plus 1, 1. 1 plus 1, sum is 0, carries 1. So 1 plus 0, 1 plus 1. So sum is 0 here, carries 1. Okay. So now this carry should be brought discarded from here and it will added here to the LSB bits. So now this carry is brought here. So 1 plus 1, 0. Sum is 0, carry is 1. So now 0 plus 1, 1. So 0, 0. So what is this is the value. So we can check here 1 plus 1. This is 1, 0, 1, 0. What is the decimal value? 8 plus 2 is the 10. And this one is the 8. So 10 minus 8, what we have? 2. So whenever minute is greater than subtrahend, you will get the extra bit. In case of 2's complement, we are discarding. In case of 1's complement, we are bringing that carry and being added with LSB. That is called as the end around condition. So it is also 1 mark question. What is the end around condition? Now another example, we have taken minute as 1, 0, 0, 0, subtrahend 1, 0, 1, 0. So here minute is smaller than subtrahend. So now subtrahend become 1, 0, 1, 0. For that we have to take the 1's complement. So 0 will change to 1, 1 into 0, 0 into 1, 1 into 0. So this is the 1's complement of the subtrahend. Now both will be added together. 0 plus 1, 0 plus 0, 0, 0 plus 1, 1. 1 plus 0 is 1. Now here what we are seeing that we don't have extra bit. That means minute is smaller than subtrahend. Now what we'll do, we'll take the 1's complement of this sum and we have to add the negative sign. So 1's complement, 1 will change to 0, 0 into 1, 1 into 0, 1 into 0. And negative sign is added here. So this is the result. Okay. So both you are saying same. Here, what is happening in this situation? We are doing 8 minus 10. 8 minus 10 is what? Negative 2. So that can be seen here. So this is how we are able to perform this subtraction with the help of addition by the complement. So complement is going to help us to perform the operation of subtraction with the help of addition here. Now we are going to talk about the signed binary numbers. So these signed binary numbers means here we are going to take the importance of the sign, whether it is positive or negative. Okay. So this positive number MSB bit will be 0. Which bit? MSB bit. And for the negative number, MSB bit will be 1. 1 will be the binary 1 here. Now, for example, if you want to write negative 9. So 9 is what generally? 1, 0, 0, 1. So it is 1 in magnitude. If you use the sign, we have to write here 1. So minus 9 is 1, 1, 0, 0, 1. But if you see by mistake, in case of, if you consider this one as the normal number and you will convert into decimal, this is going to be equal to how much? 16 plus 8. 24 plus 1, 25. Okay. But computer is going to understand negative number when MSB bit is 1. So that is considered as the negative by the computers. So this negative numbers we can represent with the help of like MSB bit 1 or for the sign consideration, or if you talk about later we'll see about BCD codes. So there we are going to give 4 digits for the sign bit also. So if you have only plus 9, so plus 9 can be represented as 1, 0, 0, 1. So what we have, add the sign here, 0. So if you are going to consider 4 bits, so 0, 0, 0. So this 4, 0 is for the sign bit and here 1, 0, 0, 1 is the actual value. Whereas the negative 9 will be written as 1, 0, 0, 0, 1, 0, 0, 1. Okay, so here MSB bit is 1. It shows that it is the signed negative number. And it also can be done with the help of 1's complement as well as 2's complement. Okay, so if you take the 1's complement of positive 9 here, so what we'll get here? 1 will change to 0. Okay, 0 will change to 1. 0 is changed to 1, 1 to 0, and remaining 4, 0 will be changed to 1. So again, MSB bit is what here? 1. So computer is going to understand these are negative numbers, and here what we have? 1's complement. Similarly, in case of 2's complement, you know that in 1's complement, if you add 1, it will become 2's complement. So last LSB bit is 0, 0 plus 1 is 1. So remaining bits will be same. Okay, this is the sign bit representation. So this negative 9 can be represented in these three ways, whereas positive 9 can be represented only with one way. Okay. Now these things we can use to perform the arithmetic addition as well as arithmetic subtraction. So this subtraction can be seen as the addition that we know already how this complement is going to help us here. Okay, so that is the important part here. Now, if we have some number for which we have to perform the arithmetic operation, okay, suppose we are considering some example like we have plus 6 and we have plus 13. So this answer should be plus 19. So both are here, what here? Positive numbers. But we are going to consider the sign numbers. So how we are going to write plus 6? These 4 bits are for this sign. 6 is written as again by using 4 bits. So 110 is the 6. So add 1 bit 0, 110. So each number is represented here with 4 bits. Again, 13 is positive numbers. So 0, 0, 0. Okay, sign is positive and 13 is written as 1, 1, 0, 1. Now if we'll add it, 1, 1, 1 plus 1, 0, carries 1, 0 plus 1, what we'll get here? 1, again carries 1, 1 plus 1, 0. Now carry can here. So 0 plus 0 plus 1, 1. The remaining bits part 0. So this is the what value? 16 plus 3. This is the decimal 19. Okay. So this is the how we are going to consider the sign bit. If one number is negative, another is positive, suppose we have minus 6 plus 13. So now for the negative number, we have to take the 2's complement. Okay. So minus 6. So minus 6 is what? 2's complement we have to take. So already we have written 6 here. So 2's complement of that, what is going to be here? Okay. So 2's complement means, what is the rule? From the LSB side, 0 should be unchanged. First 1 unchanged. Remaining bit will change. 1 into 0, 0 into 1. Okay, like this we have. This is the 2's complement of 6 here. Since we have negative 6, so we have to take the, for the negative number, we have to take the 2's complement. And 13 we'll write as it is since it is the positive number. Okay, so now we'll perform the addition operation. 1, 1, 1, 0. Now it will add, going to add here. This all is going to become the 0 and we get the carry as the 1. So whenever carry is going to obtain in this situation, if result is positive that you know, so this 1 will be here discarded. So this is the value what here plus 7. Okay. Similarly, if two numbers are negative, so again we have to take that 2's complement of both numbers, then we are going to add the numbers. Okay. So in this situation, what we have seen, we have minus 6 plus 13 we can do in this way. If you have suppose plus 6 minus 13, then what is the answer? Answer is the minus 7. So for this 6 we are going to write as it is, positive number. Okay. So 0, 1, 1, 0. Minus 13. So for plus 13 now we have to take the 2's complement. So I am writing directly here. This is the 2's complement. 0, 0, 1, 1. You know how to find the 2's complement. Zeros unchanged from the LSB, zeros unchanged. 1 will be again unchanged. First one unchanged. Remaining bits, 0 will change to 1, 1 will change to 0. So already what we have here, plus 13 is this. So here what we are saying, LSB bit itself is the 1. So this 1 is unchanged. Remaining bit 0 will change to 1. 1 to 0, 1 to 0, okay, and 0 into 1. Now it perform the addition operation. Okay, here all we have addition. So now we'll add here 0 plus 1, 1, 1 plus 1 sum is 0, carries 1. So 1 plus 0, 1 plus 1 sum is 0, carries 1. So now again it is 1 and remaining all is going to be the 1. So this is what here, it is not actual results. Now what we have to take? We have to take the 2's complement of this and we have to add the negative sign. That is going to be the answer. Similarly, if you have both numbers negative, minus 6, minus 13, so we have to take the 2's complement of both numbers. Okay. So minus 6 already we have written earlier. So this is the value, 2's complement. So 1, 1, 1, 1, 0, 1, 0. Minus 13, just now we have written 1, 1, 1, 0, 0, 1, 1. Now we have to perform the addition. Okay. So after performing the addition, what we are going to get here, 1, 1 plus 1, sum is 0, carried 1. So again, you will have 1 here, again 1, again here 0, and remaining is going to be again 1, 1, and here 1 carry we are going to obtain. Okay. So whenever result is negative, we have to take the 2's complement and we have to add the sign bit here. Okay. 2's complement we have to take. So for this again, we will find the 2's complement. Okay. So whenever result is negative, that for obtain sum, we have to find the 2's complement and we have to sign bit. Okay, for this, we have to add. Okay, this is how we are going to perform the addition, arithmetic addition. Okay. So now if suppose we have to perform the subtraction, this was the completely arithmetic addition. Now in case of arithmetic subtraction, you'll see that it can be done with the help of addition that we are talking from starting onwards. So in this situation, if you have like minute is either positive or negative number and that we are going to perform the subtraction, and here subtrahend is also positive. So this can be written as plus minus a. This is the minute. And here we can write the plus and inside minus. Okay. So same addition, but here some subtrahend is going to become negative. So for this negative, we have to take the 2's complement. Again, if you have situation like this, plus minus a, and here we have minus, again number is also subtrahend is negative. So we'll have plus minus a plus b. So directly here you can see that it's looking at the addition. So like this we can do, okay, arithmetic operation. So this is the discussion here. What is the complement and how we are going to utilize the complement to perform the subtraction operation with the help of addition. So any doubt is there, write in the comment box, like, share, subscribe.